Hello, my name is Gary Owens, and for our senior design project, we designed a new gas turbine fuel control and protection system. One of the major performance enhancements we were trying to achieve was a better load rejection response. The existing customer system often did not stay running when major load swings above 1 megawatt occurred on the system, either flaming out the engine if the fuel cut back too much or overspeeding the engine if it didn't cut back fast enough. The new design features a faster cycle time in the controller and also faster can open serial connection to a new modern fuel valve. While simulations were used during the factory acceptance test, the load response could not be simulated as the real system has mechanical variables that are not modeled. So our first chance to test this was at the customer site during the recent Phase 1 commissioning plan. Once we were able to start up and get the engine up to speed and parallel to the utility, we raised the generator power to 1.5 megawatts as a starting point for the test. This is a power swing that had about a 50% chance of shutting down the old system. After a few attempts and some fuel tuning, we were able to get to the following trend. The green line shows the generator load, and as you can see, it is around 1480, so just under 1.5 megawatts at this point, and it was dropped almost instantaneously to zero by opening the generator output breaker. The upper curve is the RPM of the engine, normally running at 14,600 RPM. As soon as the breaker opened and the load went away, the speed got as high as 14,840 and then swung back under to 14,420 before coming back nicely to 14,600. The speed was very tight and the loop was tuned and behaved very well. The red line down here just shows the fuel valve demand, and it's also well behaved. The steps here that make it look jagged are based on the resolution that's set up in this trend software. It's currently set, or it was set at the time for 160 milliseconds between changes. But this is speed corresponds to approximately 59 to 61 hertz from high to low. This is well below the 57 and 63 hertz trip points and the customer's desired 58 to 62 plus or minus 2 hertz swings that they wanted to achieve. So as you can see, we've had some very good results at the 1.5 megahertz range. We're going to do future testing with higher, maybe up to 3 megawatt load swings, and continue to tune and get the system to behave as best we can. But things are very promising, and the customer is extremely happy with the initial results. Thank you.